You might think you mastered this in middle school physics, but if your teacher had explained it like this, you might have become an engineer at NASA. Let's start with a soul-searching question. The fundamental function of a resistor is to turn useful electrical energy into waste heat. So, why on earth is it found in almost every single electronic device in existence? To understand why, we first need to understand what resistance actually is. At its core, electric current is simply the directional movement of electrons through a conductor. However, conductors aren't perfect. They are made of crystal lattices of atoms. As electrons travel through, they inevitably collide and rub against these atoms. This constant friction causes the atoms to vibrate faster, which creates heat. This obstruction to electron flow is what we call resistance. According to Ohm's law, current equals voltage divided by resistance, I equals volt per revolution. Therefore, if the voltage stays the same, increasing the resistance will decrease the current. A resistor is simply an electronic component designed specifically to provide this resistance to control the flow of electrons. The structure of a standard resistor is actually quite simple. It usually consists of a resistive material wrapped around an insulating ceramic core. The type and length of this material directly determine the resistance value. Leads are attached to both ends to connect it to the circuit. And finally, the whole thing is sealed in a plastic or ceramic coating. While they come in many shapes, this core structure remains the same. But here is the big question: since the resistor's job is just to limit current, why don't we just set the power source to output the exact current we need in the first place? Why bother adding a resistor? Here is the reality: complex circuits contain many different components like speakers, sensors, and microchips. Each of these components requires a different amount of current to function safely. A resistor acts like a valve, distributing the exact amount of current needed to each specific part of the circuit. Without them, sensitive components would fry. Beyond the basic fixed resistor, engineers have developed functional variants for all kinds of tasks. First, we have the potentiometer. Inside, there is a resistive track with a sliding contact. As you turn the dial, the position of the contact changes, altering the resistance and, consequently, the output voltage. This is the mechanism inside your old-school volume knobs. Next, there is the photoresistor or LDR. Its resistance is inversely proportional to the light hitting it. The brighter the light, the lower the resistance. This works based on the photoelectric effect in semiconductors. When photons hit the material, electrons absorb energy and break free, becoming conductive. By pairing this with a relay, you can create automatic streetlights that turn on when the sun goes down. Then we have the thermistor. These utilize semiconductor materials that change their electron activity based on heat. Usually, the higher the temperature, the lower the resistance. These are essential for temperature controllers and sensors in your devices. In short, while the resistor seems simple, the variety and utility are endless. Circuit engineers use them to pull off all sorts of magic. That covers the basics. Did you truly understand it this time?